Okay, the question says find all solutions to the system of equations, and we have blah, 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 and blah, blah. Whenever you see a system of equations, your first thought is, can I add or subtract any set of, or any two equations in order to simplify the situation? So you could say, okay, is there any z anywhere else? If I find a z somewhere, if I had like a minus z there, then maybe I could combine this and this and get rid of the z. Or if I had a minus 2z, then I could multiply this to get 2z, 2y, and 26, and I combine them to get rid of the z. But the z is only in one place, so that doesn't work. How about the y? The y is also only in one place, so that doesn't work. The x is only in one place, that doesn't work. X squared, the same thing. So the only thing that's in two places is the yz. So I need to focus on the yz, these pair of equations. What I can do is I can add the first one to the second one. Let's call the first one I, call the second one II, and call the third one triple I. I can add I to II and simplify the thing quite nicely. So let's do that. I'm going to add x squared to x, and that'll give us what? Well, let's tell our teacher what we're doing. We say add I to II, and that'll give us x squared plus x is what? X squared plus x. Can't do anything with that. Yz plus minus yz is what? 0. So nothing there. Equals to 39 plus minus 33 is the same as 39 minus 33. That's just 6. So then this is becomes just a normal quadratic equation. So we can say that gives us x squared plus x minus 6 equals 0. And we can try to see if it factors. Does it factor? We put an x and an x. Does anything multiply to give us minus 6 and add to give us plus 1? I think so. I think minus 2 and 3. Yes, minus 2 and 3. Okay, which would then give us that x is equal to 2 or x is equal to 3. So now we have two possible values for x, and we're going to plug those values into these guys to see if we can work out y and z. So let's split up our universe now into two worlds. We have the first world and the second world. In the first world, let's say that x is equal to 3. I'm going to plug this into either equation 1 or equation 2. Let's, for now, since equation 2 is simpler, it has just an x, we plug it into that one. So we plug into II. Okay. And actually, let's highlight this 2 and 3 that we solved so we can come back to it easily. So we plug this into II, and that's quite simple, right? So we just put a minus 3 there. Sorry, I made a mistake. Sorry, x plus 3 gives us x minus 3 here, and minus 3. Okay, so we have a minus 3 plugged in for there. Minus yz is equal to minus 33. And then that gives us minus yz. I keep writing my z in this funny way, and I know it confuses people. So let me try and change it. Let's write the z like that. So minus yz then is equal to minus 33 plus 3 is just minus 30. And then we have that yz. Oh, I did it again. Yz is equal to 30. And we can write y in terms of z or z in terms of y. Let's do y in terms of z. Y is equal to 30 over z. Beautiful. Now this thing, we can take it and plug it into equation 3. Because if we can figure out y in terms of z, if we had instead of a y, we have 30 over z, then this equation just has one variable. It's an equation in z, and we can solve for z. So let's do exactly that. So we plug in there. So let's tell our teacher again what we're doing. We say plug into triple I. Okay. And we would just do, instead of y, we write 30 over z plus z is equal to 13. And to get rid of this fraction, we can multiply both sides by z, right? Multiply both sides by z, and here we get 30, right? So this times that, 30 plus this times that, z squared is equal to 13z. Okay, and now this just becomes a regular quadratic. So let me scroll down a bit. So we have now z squared minus 13z plus 30 is equal to 0. We solve for z. Let's see if it factors. I think this one factors. So what would be the factors of 30? See if they add to 13. Let's say we have 30. 3 times 10, yes. Then 5 times what? 6. Then what else? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15 times 2, right? Okay, let's try 3 and 10. 3 and 10, so if we have maybe, if it's plus 30, it must be both positive or both negative. So 3 plus 10 would not work. How about minus 3 minus 10? Yes, that would work. So x minus 3, or z minus 3 and z minus 10. So then finally we have that z is equal to 3 or z is equal to 10. Okay? So remember, we had said x is equal to 2 or minus 3. And in the world where x is minus 3, z is 3 or 10. Let's highlight that x so we can keep track of it. This one. Okay, so now we have z is equal to 3 or z is equal to 10. And based on either of these z's, we can solve for the y, right? Because y plus z is 13. Okay, or you could also use this one, y equals to 30 over z. Let's use that one since we can see it. So we have that y is equal to 30 over z, which is 30 over 3 in this case. So y is equal to 10. Okay, so we have that first one. And then we have also that y here is equal to, instead of 30 over z, here we have 10 over z, which is equal to 10 over 3. Wait, sorry, I'm making a mistake. No, it's still 30 over z. Y is equal to 30 over z. But that, in this case, is going to be equal to 30 over 10, which is equal to 3, right? So we have y is equal to 3, I think. Okay, and so let's highlight that. So then finally, let me make sure I know what I'm doing. Yes, I think we're still on the right track. So finally, our answers here in this universe would be, we have an x of minus 3, a y of 10, and a z of 3. That's one point. This other point, we have an x of minus 3 again, minus 3, a y of 3, and a z of 10. Okay, so we have there our two solutions. And now you can go now to the second universe. This is our universe 1. Universe 2, x is 2. And we take 2 again and we plug it into equation 2, just as we did before. So instead of minus 3 minus yz, we would have 2 minus yz is equal to 33. And we'd solve for y and plug y into each of these things, right? Sorry, what do we do? We took y and we plugged it into equation 3, and that allowed us to solve for both y and z. So the exact same thing I've done on the left, you would just do it on the right. My brain is tired, so I'm not going to do this second one. But try it and see if you can get it. And of course, you can look at your teacher's solution. As long as you understand what she did there, then you're in good hands. And I'll try to see if I can get a similar question here to give you. Okay, good luck.